not going to finish the lecture today. I should be fairly close. So what we'll do is we'll just wrap that up at the start of lab tomorrow, which will be good because I think I'll get all the way to just the little introduction to Docker. So it's not a bad way to start out the lab by giving you a little tutorial on Docker. Some of you are probably already familiar with Docker and know what you're doing, so you guys can be prepared and ready. All right, so what we want to talk about today is virtualization and containers. And then the standard disclaimers. So there's some reading material. We want you to read a little bit on both virtualization, what virtualization means, a little bit on virtual machines and Docker, and then Oracle has a VirtualBox reference. When we talk about virtualization, we're largely going to go with the Oracle VirtualBox, although you can, any of the big cloud platforms have their own virtualization strategy, and they all function about the same, the same concepts. So, introduction. So, what is virtualization? So, the whole concept behind virtualization is that. So, the whole concept behind virtualization is that you have you create a virtual rather than actual version of something, right? So you may hear the claim that we are more likely to be living in a virtual world than a real world. I'm not sure I buy that, but okay. And what that means is that we are in something that simulates being an actual real world, but it's being run on a computer. So can I do the screen share again? The webcam quality is low. I can try it. Yeah. Oh, I'm sorry. Now I understand what you're asking. You're asking me to do what I thought I was already doing. And I'm not. No. You are absolutely right. There we go. I was just confused. Okay, is that better? Awesome. Thank you for calling that to my attention, because this is what I thought I was doing, and I stopped screen sharing when the rest of you were presenting, apparently. That's why we should always do this at the end of the class instead of the beginning. Anyway, so it creates a virtual rather than actual version of something, including virtual computer hardware platforms, storage devices, and computer network resources. So when you think about it, what this means is that, for example, when we're in a virtual environment, it looks like we have a hard disk, but we don't have a hard disk. What we have is a simulation of a hard disk. Now, eventually, that has to get back down to our hard disk. So there's this tie in layers that take our virtual system and tie it to something concrete. But as far as we're concerned, that virtual thing exists with us, and we can do things like make it travel with us, and of course now I'm on the wrong screen, so I can't change slides. There we go. Travel with us, and we were afforded some protections from other people running on the hardware, and they're protected from us as well. So when we consider this, when we talk about virtualization, we're going to talk about two main types. The first type are virtual machines, right? These are your virtual boxes, your Oracle appliances. They allow a piece of hardware to run multiple operating systems at the same time. And again, VirtualBox is kind of our exemplar of that. The interesting thing about this is, what was I going to say about this? I've lost my train of thought. Anyway, so virtual machines, they allow a piece of hardware to run multiple operating system images at the same time. So this is your virtual world. You're living in a virtual world. It looks like you have sole access to the machine, but in reality, your computer may be hosting half a dozen different avatars, all running their own different worlds and universes. The other type, so they look like standalone computers. The other part of virtualization, the other type of virtualization we're going to consider is something called a container. And the difference between the two is that a virtual machine simulates the entire machine. So it looks like you have the entire machine. A container simulates essentially an application layer. So it looks to the application layer that it's the only thing running on the machine, or only those things that you set up are running on the machine. And you can build your own environments and host like Linux applications on a Windows machine, but you don't have a complete computer sitting there. You have a lightweight standalone executable package. So you have everything you need to run your software. And from the standpoint of the software, it looks like you have a virtual environment, but it's actually much more lightweight and tailored specifically to a different job. We're going to start out with virtual machines. They're, for a long time, they were the only thing that was available. And they still have a very good usage record, and they're widely available. So the concept behind virtual machines, as we talked about, is you have something that emulates the entire computer for a specific subset of the computer, for a specific a virtual machine. So this would be the hypervisor layer. All of your virtual machines can kind of sit up there. Your virtual machine can be running just like it's running on its own machine, but instead of actually writing to the hardware, it writes to the hypervisor, and the hypervisor takes responsibility for making sure that things from the virtual machine interact with the computer hardware in the right kind of way. So on this virtual machine, you then can run a guest operating system, or you can run multiple guest operating systems, and then you can have applications just like you would in any other operating system on any other computer. You can have applications running that are specific and are kind of siloed. So application C can't talk to application B can't talk to application A, at least without using normal protocols that would allow you to talk to an application running on a different machine. You are kind of working in here, and as far as you're concerned, you are running on a machine, and you are the only one there, or only the people that you've let in are there, and you're kind of just continuing to work. This diagram and everything can be found at on Docker's website. And by the way, Docker has a lot of stuff about virtual machines, and while they're pretty much a direct competitor with virtual machines, they recognize that they are also a valid paradigm, and I didn't find too much there, too much trash talking there. So I think that this is okay. It's a really good kind of visualization of what a virtual architecture looks like. So the advantages of virtual machines is that you can have, if you've taken operating systems, I don't know if any of you have yet, but if you've taken operating systems, you know that one of the things we like to do is we like to run multiple threads on our machines so that we are using all the cycles that are available, right? That's what all the scheduling algorithms are trying to do. Well, this goes for more than just the cycles of the CPU, right? It goes for your network, it goes for your disk. All of those have patterns of usage, and what you would like to do, if you paid good money for that computer, what you would like to do is you would like to have that computer working hard for you all the time. With a virtual machine, you can ensure that it's working hard all the time. I'm not as big a fan of virtual machines as I am of containers, but the idea there is that if you have jobs that don't require all the resources of your computer, you can get better access, better resource management of the actual hardware by sharing it among multiple virtual machines. So if each machine only needs 10% of your hardware, you can host several of those, get more done, and better utilize your machine. They also have better security. So you will almost, I don't know of any cloud services company that allows you to directly log into their hardware. What you do is you log into a virtual machine, and they do that because they can make you run in an isolated environment. So as far as the virtualization goes, you are completely cut off from the actual hardware, and you're completely cut off from anybody else running on that machine as well. So they can, kind of segregate you or isolate you and make it so that you can't affect other people running on the same machine, other than, by impacting their runtimes by using I have a note here, dedicated cloud servers do exist. They're just less common and more expensive. I think that's reasonable. So anyway, you get better security because you are siloed, right? Your computer, your virtual machine, while it looks like you have access to the entire machine, you're actually running in a little isolated pod, and you're not going to hurt anybody. And the other part of it is you can have the same hardware running multiple operating systems. So for example, if you're running testing code and you need to test on Windows, and you need to test on Ubuntu, and you need to test on RHEL, and you need to test on OS X, right? You can run multiple machines at the same time on the same hardware without having to put out money for all of the different versions of the hardware that you're trying to test on. So those are some good advantages of virtual machines. Virtual machines are widely used. They are very useful. Another good one is an entire environment can be distributed. So if you've gone onto a complex project, for example, I know that at least a couple years ago, YAX was extremely hard to build, and some new students coming in were spending the first half to 2/3 of the semester just getting YAX to build. Well, what you can do is you can clone up an environment in a virtual machine, and you can distribute the environment with all of the dependencies that the students would have to, or that your group would have to install separately, already installed on the virtual machine. You can keep versions up to date, and you can keep the complete development environment. So not only can somebody run, not only can you have a virtual machine that can run your project, but you can also have a virtual machine that has all of the development tools installed as well. And what this does is instead of having to spend a lot of time setting up environments and downloading all the dependencies and making sure you have the correct versions of everything, you can maintain them just in a virtual environment, and you run into less confusion about versions or compatibilities. When you trash it, you can always reload and start from the previous state. So if you do get an incompatibility, you can recover from it. You can checkpoint the machine state. So as you upgrade Node to the next version, you can checkpoint before you upgrade Node. You can install the next version of Node. You can make sure it works. And then if things go seriously wrong, you can go back to your checkpointed version and start again. So that's another really big advantage. And part of that is that, let's say at one point you're running for 7 people. You're not doing any development. You can be on a less powerful machine. Now you want to do some development. You can migrate your environment just by checkpointing and transition it to another more powerful machine. You can get more cycles to do your development, or maybe you've gone from seven users to 3,000 users. Your small machine is no longer available, or is no longer sufficient. You can migrate to a more powerful machine and run with no loss. As far as the users are concerned, you may not even see a blip when you change over to the more powerful machine. So you can do this migration up and down. And in fact, if you're checkpointing, if you're taking your status every now and then, and you actually do lose a physical hard drive, or somebody kicks out your power supply, all you have to do is transition your last checkpoint to a new piece of hardware, and you're back running without having to do a lot of setup on the new machine. It's all contained within the virtual environment. So it gives you the ability to kind of move around and ensure that your software is always pretty much ready to be used. So there are a lot of advantages with these virtual machines. Disadvantages. Well, some of the advantages are also disadvantages. So virtual machines share resources, memory, disk, network bandwidth. Poor planning and multiple VMs can drown a machine. That is where I almost always sit. That's why I'm not a big fan of virtual machines. It's just because from my standpoint, I never provision them correctly. I always have insufficient memory, disk, and network bandwidth, and running a VM will eventually bring my machine to a shuddering halt. This is becoming less of an issue. I think even Microsoft has free licenses now, but you do have to abide by the considerations of the multiple licenses. If you need to license your software, you need to make sure you need a license for every version you're running. Unless you have a group license for Windows, maybe you need 7 Windows licenses to run your 7 virtual machines simultaneously. There are some purely political issues with licensing, etc. And then the other thing is, it's great that you can run multiple machines on a single set of hardware, and that you can recover quickly if your machine goes, if your hardware breaks by popping your virtual machine onto another set of hardware. But the converse is always also true. If you have a big system running multiple VMs, a problem with one piece of hardware can take down, a whole slew of services or a whole group of servers virtual machines that you have serving your customers. So, it's kind of the same side, a flip side of the same coin. You can distribute an entire environment, but that means that this entire environment has to be represented in the virtual machine file. So if you've looked at some of these virtual machine files, they can be huge, right? Because they have the guest OS, right? So you have an entire Windows install. You have however much disk you want to have in there has to be represented somehow in the VM, and certainly any things that you've stored out there can't be, have to be represented. You can't write files to your disk and not have them show up in the virtual machine. Memory, the same thing. Whatever your running state of your program has to be represented somehow in this virtual machine file. So that's big. And then each environment also communicates through the hypervisor. And this is not a zero resource piece of software, right? The hypervisor actually, slows down your communications with the hardware. So if you're going to communicate to the real hard drive, or you're going to communicate to the network, or you're going to communicate with the underlying operating system, anything you do has to go through this hypervisor, and the hypervisor adds latency, and it can significantly impact performance, particularly as you get more and more of these VMs running. And then, just like your entire environment has to be represented in your VM file, well, if you're going to checkpoint, right, you have to checkpoint all the stuff required to get you back to this exact same running state. So these checkpoint files can be huge as well. Now, again, I have confirmation that there are hosts out there that allow you to run on the bare hardware, bare iron, but this is the de facto way of using cloud compute resources. And the good thing is you are protected by the virtual environment from interference from other VMs. You essentially, other than the fact that they're contending for the same resources on the actual iron, you're protected from the other VMs, and conversely, and sometimes fortunately, they're protected from you as well. And again, you can, if you're running on a certain level of AWS and you find you need more power, more capability, you can easily add more VMs or migrate to more or less powerful VMs as your needs change. Migrate to weaker ones or less powerful ones when you're not doing much and you want to save money, and more powerful ones when you need the response time, when you need the bandwidth. And then you can, if you're getting that big, probably you're bringing in enough money to pay for the more powerful one. One of the things here is that they normally sell these by different tiers of capability, but you don't actually know what hardware you're running on all the time. I guess sometimes, there's no reason why they can't tell you, but you don't necessarily know. And one of the things that can happen is that there can be performance penalties on different systems that look like they're the same. They can also be performance. If you go to one of these places, you can get a cluster that's on the East Coast, and maybe that's a little bit different than the stuff running in Kansas. And certainly the amount of time it takes, the number of hops it takes on the network to get there can be different. So, the systems you're running on, or the clusters you're running on, or even the different locations you're running on can actually have an impact on your performance. And it's not necessarily something that you have a lot of information on unless you kind of dig into the environment. So that's kind of something you have to be a little aware of. Choose some, if you're at least monitor it and make sure everything's working, kind of the way you expect it to. Okay, quick example. I'm not going to do a lot here, but when was this? Probably about 6 or 7 years ago, maybe 8 years ago or so. The Veterans Administration, if you're familiar with the Veterans Administration, they are the medical center, or they manage a bunch of medical centers for veterans from the United States Armed Forces. And they have been in the process of trying to refit their computer systems. They were one of the first electronic health records, wide installations. They developed their own as something called Vista, or eventually became called Vista. And they were in the process of trying to replace that with new software. So under a America Competes Act, so this was about 2011, so maybe 10 years ago, they took a problem they were having with their existing software systems, and they created a contest, as it were, to write code that would allow them to do better scheduling across all of the VA hospitals, maximize resource utilization, minimize wait times for veterans looking for specific procedures, and provide access to resources in proximity to different VA hospitals, both sharing, things like supplies, as well as allowing veterans to go in and pick pick the closest appointment to any VA facility within a certain radius. So they held this big competition. I was part of the group that oversaw the technology of the competition. The prizes were awarded on or about September 30th of 2013. Okay, so it was 2013 apparently. And they opened this up to anybody who wanted to make anybody who wanted to write the code to do this. And the way we did this was we had a VA installation. It came with dummy data. It came with the existing Vista EHR, electronic health record system. We wound that up. We wrapped that up into a VM. And then anybody who wanted to register got one or more of these VMs, based on requests. I think we allowed up to 5 VMs for them to run on. We allowed them multiple VMs, both because they were supposed to communicate among different installations and because they could have multiple people working on it at the same time. So it was kind of a two-pronged thing. They ran on Rackspace. So I always like to give Rackspace a little plug. They did very, very well by us when we were trying to run this, but they're just a general cloud solution. When we told them we needed to checkpoint and validate all of these VMs, they had a little bit of a hiccup. They were just starting out at the time. I'm sure they're much less scared about checkpointing dozens of VMs and sending them to us for evaluation than they were back in 2013. And then all we did was we let them go off and compete. They had months, I think 3 or 4 months to compete. At the end, we evaluated. Well, we didn't evaluate. We passed along to the VA. We didn't want to be at all caught up in the politics of selecting a winner. We were just the people who ran the technical side and helped the VA run the submissions. There were 3, a first, a second, and a third place winner. So here was the first place one. It turns out that this was probably a little bit of a political decision, because this was actually if I'm not mistaken, this was a hospital that was using the VA's EHR, their electronic health record code. The code was open source. They were using it in their hospital environment, and the VA was trying to make political points and political connections with this particular group. But they did also, because they were actually running a hospital, they did have a pretty good feel for what was actually needed in the scheduling algorithm, and they did have enough people working on this open source Vista that they did actually know a lot about the code they needed to write. So anyway, there were three winners. This was one. This was the second one, and the third one. I'll open both of those up. And they all got, I don't know how much money they got, but they did win. Oh, I'm sorry. This is the Oroville Hospital. They came in second. So yeah. So that was a quick little tour of one way we've used VMs on a fairly wide scale. The beauty of the VMs were they allowed us to roll up the environments. Everybody got the same environment. Everybody got access to the same synthetic data, right? You have to have, if you're going to be scheduling patients, you need to have patient data. So they had the same anonymized or synthetic patient data in the system. And the other beauty part of it was, by being able to checkpoint and then transfer the checkpoints, we were able to independently evaluate outside of the contest environment. So yeah, any questions? This whole open source Vista is actually a really interesting situation. The VA has been developing code for their EHR since the 60s. They were using, you may, if you've hung around here long enough, you may have heard of a language called MUMPS, or M. It was a combined database language, so your database was kind of contained within your programming language. It became an open source project. It was always developed inside the VA as a distributed project, because the different VA hospitals would collaborate with it. So they had ways of passing code back and forth, kind of like our repositories, but certainly not with the sophistication of Git. I think they largely used patch files, or they largely used patch files to update one another. Back after the Freedom of Information Act was passed, it turns out that any project, any software or documents written by federal government employees became subject to Freedom of Information Act requests. And that included the EHR systems from the VA. So people began making Freedom of Information Act requests for this software. Generally, people who had worked in the VA previously and who were now working in a private hospital wanted to get their hands on the software so that they could have access to what was at that time world-leading electronic health record software. And in order to keep up with these FOIA requests, the VA decided to just make the code open source and hired a group of people to manage it. I was one of the people that was helping to manage that software as they tried to make it open source and viable in the commercial world. All right. Anyway, VirtualBox, it's from Oracle. If you go there and hit the link, what you'll find out is that I haven't modified these slides, this slide, at least in 2 years or a year and a half. So it's now gone from version 5.2 to 6.1. But I do have 6.1 installed on my machine. It works as well as can be expected. It kind of kills whatever you're trying to run, just like any other virtual machine if you don't have it provisioned correctly. And it doesn't play well with my recordings because it kills everything you're trying to run. But I can bring it up, I think. Oh, it's under Oracle. So doesn't that just drive you nuts when you have something called VirtualBox, but it's under O in your menu for Oracle instead of V for VirtualBox? All right, let me go on while I'm waiting for that to pop up. Hopefully it'll pop up. Okay. VirtualBox is licensed under GPL version 2. They do have some extensions that work with VirtualBox that are not licensed under GPL version 2. They're licensed under the FEU, some other license. So they aren't open source necessarily, although as long as you're not, as a commercial entity, you're free to use them. But if you are a commercial entity, then you need separate licenses to use the client software, I believe. They do have extensive documentation. This is an open source project maintained by Oracle. So you can come in and you can look at all of this, and you can actually download it here as well. I don't think I need to go to the download, but here's the abouts. You can look at the contribute, right? How to contribute. They do require a contributors agreement, or that your contribution be submitted under the MIT license. That kind of protects them when they use your code. They have a Subversion repository that we can get to in a second. And somewhere in here, your community, they have documentation on I was trying to find the client software, the license for that. I'm not actually finding that, but it's a FEU. It's some Oracle generated license that allows you to contribute code to the client builds, but it's not necessarily completely open source. Hold on. The extension pack. They're released under the VirtualBox personal use and evaluation license. It wasn't F, it was P. So you should read through that, but it's doesn't apply to the base VirtualBox code that's under GPL2. If you're going to use these, it's a separate license. And you can see that the issue here is personal use, educational use, or evaluation, non-commercial. So yeah, that definitely doesn't fall under the open source licenses. All right. Anyway, let's move on from here. VirtualBox has been around a long time. VirtualBox has been around longer than Git. So VirtualBox uses SVM, which is the Subversion repository, or Subversion code repository system. You'll have to use it. You'll have to learn it if you want to contribute to VirtualBox. But SVN actually replaced an older standard, which was CVS, which replaced an even older standard, which was RCS. So Git is one in a long line of repository software, version control software that has been available. It has the VirtualBox itself runs on Windows, Linux, Macintosh, but it has a number of guest operating systems that you can install for Windows, for DOS, for Linux, even old Sun Solaris operating systems. They have an entire list of guest operating systems here. So you can see that there's a bunch in the Windows family. There's more in the Linux family. There's Solaris. These are the ones that run on Suns. They have some Mac OS X stuff. Lots of different operating systems you can install. You can even go back to old tried and true DOS if you want. Anyway, all of those are available. VirtualBox is open source. Not all of the operating systems you install on VirtualBox are open source. So again, we're back to the licensing issue. If you're using something that requires a license, you have to execute the license appropriately. And that's what it looks like, kind of. Looks more like this on my machine. Come on up there. Okay, it looks more like this on my machine. Oh, clicked in the wrong place. Clicked on the wrong place. There we are. So here's VirtualBox on my machine. I have an Ubuntu installation up. You can start it running by hitting start. I'm not going to do all that because I don't actually want my system to go to any more of a crawl than it is in right now. But this is what it looks like. You configure it with some base memory. How you want it to boot. You can have some video memory. You can set up some storage. All of this is available, and you can set and change any of these if you'd like, including sharing folders and controlling your USB. All right, and I don't actually want to do that. I just clicked accidentally. All right, so lots of ways to configure that and make it so that your machine is completely unusable if you're not careful. You can start it, you can stop it, you can checkpoint it. Checkpoint it essentially saves the current state, so you can start from there the next time. And again, I am not a big VirtualBox fan, although I have used it extensively and I used it a lot when I needed to. It does drag your machine down. When you're encapsulating that much data in a virtual image, you're stealing it from the rest of your machine, so your responsiveness will suffer. You need to be aware of that. But it is a great product because it actually is open source and it allows us to do what we need to do. So, despite the fact that it's not my preferred choice, it is really powerful and really important. All right, so